Good day, everyone. I am Daryl Tenorio, and I'm going to present a paper regarding a face mask and contactless temperature detector. In March 2020, the World Health Organization had declared COVID-19 as a pandemic. The pathogenesis of COVID-19 was still unclear at that time. But because COVID-19 is similar to other coronaviruses and respiratory diseases, it indicates that the disease can spread through large respiratory droplets and direct or indirect contact with infected secretions. Wearing a face mask is mandatory when a person is in a public place to curb the spread of the virus. However, there will be problems in complying with the guidelines of wearing face mask among the people in the library of Seberang Perai Polytechnic in Malaysia. To overcome this, the researchers have developed a project that involves setting a face mask and temperature detector. COVID-19 has infected millions of people around the world and has caused death to many. In order to save lives and prevent the global economy from getting worse, we need to take precautionary measures to prevent the spread of the virus. The droplets coming from a cough or sneeze of an infected person becomes the contagion of the disease. And if someone has inhaled or touched a surface where the droplets landed, he or she might get the virus. People are asked to practice social distancing by keeping at least 1 meter away from each other. But with the rising number of cases in Malaysia, the government has mandated the public to wear face masks and take temperature reading before entering in all public places. Those people who will show common symptoms of the virus like fever, cough, can be prevented from entering the place, and that could reduce the virus from spreading. A normal body temperature is between 36.5 to 37.5 degrees Celsius. Anything recorded above this is considered as fever, indicating a viral or bacterial infection. That is why the researchers came up with the idea to build an innovative product that measures the temperature using a contactless detector integrated with a sensor that can detect wearing a face mask. The goal of this project is to take simple steps in controlling the COVID-19 pandemic that can be easily spread in any public places. With this, students and staff of PSP can ensure that they are in a safe state while inside the campus and in a library where a lot of interaction between students happen. Because if a student is not wearing a face mask and shows common symptoms, he or she might carry the virus and can spread it easily in that confined place. But with the innovative product, we can detect those people who are not wearing face mask properly and those body temperatures beyond normal. The agile methodology was chosen to implement the SDLC process, which can cater changes and allows much flexibility than those traditional methods. Clients can make small objective changes without huge amendment to the budget or schedule. If there will be any problems encountered, as this can be made during the production cycle to fix the issue. Several phases in the Agile model which will be used in this project are planning, analysis, design, implementation, testing, maintenance. We'll start with the planning phase. During this phase, the need for FMT detectors was identified with the stakeholder, who is a PSP librarian. In order to solve the problem of no controls being done with the movement of students who are not wearing face masks and may have symptoms such as high fever into the library. Objective setting is also set to ensure the goal of the product. Upon discussion, the FMT detector will help achieve these objectives. First, to detect and display the temperature reading of those entering the library. Then, to track and remind students, staff, and visitors entering the library to wear face masks by displaying an indicator mark on the screen. Lastly, to alert students, staff, and visitors whose temperature are 37.5 degrees Celsius and above, or no face mask is detected by displaying an indicator mark on the screen together with a buzzer sound as a warning. FMT is a self-examination detector tool for the use of students, staff, and visitors of PSP Library. Next is the analysis phase. During this phase, the research was carried out based on the project requirements. The needed software, hardware, and programming language to be used are determined. The project will use a webcam, a MLX 9061 for contactless temperature sensor to read the body temperature of the scanned visitor's face. Then, the temperature reading will be shown on the screen display using the Raspberry Pi 3B board character LCD display with a tick sign for permission to enter the library and a cross sign for not allowing the visitor to enter if the temperature is above normal. If the user is accessing the Raspberry Pi remotely, a device compatible with VNC Viewer and VNC is required, such as PC, laptop, or smartphone. A warning sound can be heard from the buzzer if the person is not allowed to enter the area. Lastly, a USB power brick to power the innovative product. Analyses were made in PSP's library. The results of interviews conducted with librarians were also analyzed to determine the requirements and project specifications. The needed features were identified in the development of innovative products such as creating a facial recognition system that can be used to identify whether a person is wearing a face mask or not. A contactless thermal sensor to identify symptoms such as high fever without close contact with anyone. These two features need to be integrated together to come up with an easy to carry face mask and body temperature detection tool that is small enough to place and use in different areas. According to Pyrosales, thermal sensors and infrared sensors are the most common types of non-contact temperature sensors and used in the following situation. First, when the target object is moving, for example, an object on a conveyor belt or a moving machine, and a very high temperature where the contact sensor is unable to function properly. Face recognition is a way of recognizing human faces through technology. It uses biometrics to map facial features from images or videos. To recognize a face, the camera must be able to identify features found on human face such as pair of eyes, nose, mouth, and lock the face using an algorithm. To prevent breaches of personal biometric data, FMTU detector will not identify faces, but will only detect the wearing of face mask on a visitor's face. Next is the design phase. During this phase, the requirements from the first two phases were studied and now being mapped in order to come up with the system design. The system design determines the overall hardware and software requirements to help the project team and the stakeholders get a clear picture of the product. It will also determine the components, interfaces, and features of the product. The physical design of the FMD is also illustrated to give the stakeholders an initial idea of how it will look like. Next is the implementation phase. This is also the longest phase in the SDLC life cycle. The researchers had identified that Python will be the programming language to be used to achieve the set objectives. Python was chosen because of its large references available for the MLX 90614 thermal sensor library. OpenCV library is also compatible with Python, and there are a lot of references with this library. A webcam will be used for the face mask scanner and will report the presence or absence of a face mask on a person's face. The MLX 90614 contactless temperature sensor will be used to read the visitor's temperature at the same time the face scan is made. The LCD is integrated with the two tools mentioned above via the Raspberry Pi to display the compliance status. Once the development is done, it will be then tested to ensure that it will work and meet the needs of the stakeholder. Once the face mask is detected to a person, the sensor will then check the visitor's body temperature. If the temperature is normal, meaning it is lower or equal to the 37.5 degrees Celsius, it will show the temperature checked on the LCD display together with a tick symbol, meaning the person is allowed to enter. But if the temperature check is above normal, meaning it is higher than 37.5 degrees Celsius, it will show the temperature check on the LCD display together with a tick symbol, but the FMT detector will emit a buzz sound to warn the person from entering. And if the FMT detects that there is no face mask on a person's face, it will display an X symbol on the LCD screen together with a buzz sound from the buzzer to warn the person. Next is the testing phase. In this phase, the system was tested repeatedly to see if there will be problems need to be fixed. Several types of testing were conducted such as unit testing, integration testing, and user acceptance testing to determine whether each component can function properly. Each test was set to a specific procedure and all results were recorded to facilitate improvement and maintenance in the next phase. Lastly, the maintenance phase. This phase occurs once the system has go live. Change requests, enhancements, and bug fixes usually happen during this phase. It also includes addressing errors that may exist even after the testing phase. And the cycle will continue until the desired overall project outcome is achieved. The result of this project should achieve the overall objectives that had been set a while ago to detect and display the temperature reading of those entering the library. This objective was achieved by displaying to the LCD screen the body temperature reading obtained from the FMT scanner. Next, to track and remind students and staff entering the library to wear face masks by displaying an indicator mark on the screen. This objective was also achieved by displaying the text a face mask equals a tick symbol if a person is wearing the face mask perfectly. It will also display the text a face mask equals a cross sign if a person is not wearing a face mask or placed incorrectly. Lastly, to alert students, staff whose temperature are 37.5 and above or no face mask is detected by displaying an indicator mark on the screen together with a buzzer sound as a warning. This objective was also achieved by displaying the warning sign indicator together with a buzzer sound to remind a person to not enter the area. Here you can see the result of the unit testing done with the staff and students of the PSP library. And here you can see the integration testing results. And here is the result of the user acceptance testing. One of the FMT detector feature is that it can detect whether someone is wearing a face mask or not. This is made possible by OpenCV and TensorFlow. It scans by using a webcam connected to the Raspberry Pi via USB. The FMT scans the face to see if it can detect a nose, mouth, ear, and the eyes. If it detects the nose and the mouth, then it means that the person is not wearing a mask, and vice versa. Finally, through the use of FMT detector, it can reduce the rate of infection from spreading faster. There were also identified limitations of the system such as the high latency between the webcam and the Raspberry Pi due to the USB interface. The temperature result glitched out. When the user is too close to the webcam, it will cause the program to malfunction. The reason it happens is that the webcam captures too many pixels and the Raspberry Pi CPU can't handle the load and that caused it to crash. In conclusion, the FMT detector uses a low-cost equipment such as webcam, thermal sensor, and Raspberry Pi 3B, which is expected to help in dealing with the current COVID-19 situation, especially in monitoring a person's body temperature and the use of face mask. This project was developed as one of the initiatives taken to control the spread of the virus among students and staff. It is very important that everyone follows the rules of mandatory wearing of face mask in all public places. And at the same time, this project was an opportunity to further increase knowledge in IoT. That's all for my presentation. Thank you for listening.